construct a truth table for the given statement, and then we have open parentheses, P or Q, close parentheses, and not P. And that's how you're going to read this. So what we're going to do is remember that we have our logical connectors. This is a disjunction. And it means or. This is a conjunction, and it means and. And we also have this symbol, which means negation, or just simply not. Now, one of the things that we need to remember for this one is the fact that there are parentheses here. That means that the order of operations will hold for this, and we're going to take care of what's inside the parentheses first, and then we'll deal with what's outside the parentheses. Now, one of the things that we want to also look at is the fact that this is given to us as an outside, but in the truth table that's given in the problem, they want us to go ahead and do this first. So let's go ahead and do that, and then we'll talk about the rest of this. So for the negation, the not P, if we look at P here, we see that P has 4 different values because of the way Q is set up. So if P is true right here, this right here is the not P, so that means this would be false. Likewise, there's a true here, so the not P here would be false. This is false, so this will be true. And this one is false, so this will also be true. So that takes care of the negation. Now we want to look at the next thing, which is the disjunction, which is this or. This is P or Q, which means that P or Q or both have to be true for this logical statement P or Q to be true. Which means that when I look at this, this is true, therefore P or Q is true. This is true, this is false, therefore P or Q is true. This is false, but this is true, therefore P or Q is true. But now here, both of these are false, so that means P or Q will be false. Now you'll notice that we have the P or Q taken care of, and we have the not P taken care of, which means that brings us to the conjunction and. So this is an and in order for this to be true, the statement P or Q and the not P both must be true. So now we have a false and a true, which means this is false. We have a false and a true, which means this is false. We have a true and a true, which means this is true. We have a true and we have a false, which means this is false. And we have created the truth table.